Hello people. What do you think should happen to the bullet after it hits the enemy? I think it should disappear because wiping out everyone in its path with a single bullet is clearly overkill. One bullet, minus one enemy. Well, not exactly. One bullet, minus one unit of durability. It's just that our enemy is currently weak, dying from a single hit. And the bullet should vanish with it. You could create a new branch and link it to the bullet, but I suggest simply adding a few blocks to the existing script called bullet move. This branch is small, and we'll add just a couple of blocks. The first block is on contact array. Each bullet will check for a collision with the array of enemies itself. So, we leave the object field empty. Connect the second channel to our collection block and choose the enemies folder. If the collision check block is triggered, then simply remove the current object from the scene with a remove object block. It seems like everything is set up correctly. What do you think? Let's give it a try. Launch the game and try shooting at the enemies. And let's make sure that bullets don't disappear from the screen after a collision. Let's tackle this issue. Only by understanding what's happening can we fix it and move forward. For clarity, I'll open two branches at once. On the left will be the branch where we remove the enemy, and on the right, the branch where we remove the bullet. Now, let's imagine that time has slowed down, and we can examine each step of the processor, tracking each operation one after another, step by step. So, the left branch. The enemy registers a collision with the bullet. The control signal is sent to the remove object block, and the enemy self-removes from the scene. In the same tick, this check occurs. The bullet checks if it collided with an enemy. Since the enemy is already removed, the check won't yield a result. Thus, the bullet didn't collide with anyone, and the removal block won't be activated. The bullet will continue to fly. The solution to this situation is simple. We just need to add a delay before removing the enemy so that the bullet has time to register the collision as well. Before removing the enemy, let's add a sleep block. In principle, the scheme will work regardless of the delay we set. But ideally, we need a delay of exactly one tick. We can achieve this by leaving the default value in the sleep block, 0. Now, after colliding with the bullet, the enemy won't be immediately removed. It will wait until the end of the iteration for all code in all branches to be executed. This guarantees that the bullet will have time to register the collision with the enemy and remove itself from the scene. Let's run the game. Make sure everything is now working as it should. And rejoice. Additionally, let's add a variable to store the current bullet speed. In the future, both the bullet and character speeds will change depending on circumstances. So we'll eventually need to move away from fixed values. Let's select the player. Go to the object properties. Add a variable of type float. Float, because we will use fractional values for speed. Named bullet speed. And assign it a default value of 0.3. For aesthetics, I suggest renaming the existing variable speed. Since we store the current player speed in it, it would be more logical to name it player speed. After renaming, we'll need to go to the player input branch and in the get object properties block, change the name to the new one. Be careful with the letters. When it comes to variables or object names, it's safer to use copy-paste. It's more reliable this way. Now let's go to the bullet move branch. Instead of a fixed speed value, let's connect the new variable. Grab the getObjectProperties block. Specify the bullet speed variable. In the object field, this time we need to specify the player object because the variable is stored in it. This branch is linked to the bullet. Why did we place the variable in the player? Well, it's more efficient this way. The speed for all bullets will be the same, so we need a single variable for all bullets. If we attach the variable to the bullet, each bullet would have its own individual variable with the same value. Connect the variable to the y-axis in the vector block and link it to the vector channel in the translate object block. Just to be sure, let's run the game to make sure everything is working. One last touch. Currently, we have only one type of enemy, but in the future, there will be several with different characteristics. Since we are setting up speed for different objects, let's add a variable for the enemy as well. Select the enemy cube, add a flow type variable in the object properties, name it enemy speed, and set the default value to 0.01. Go to the enemy move branch, find where we set the speed for our enemy. Right here on the multiplication block. Add a getObjectProperties block. Leave the object field empty. Specify the enemy speed variable and connect it to both multiplication blocks instead of fixed values. Test the game one last time. If everything works, then you can go relax with a clear conscience. Goodbye for now.